So in our last video, we came to the conclusion that the demand curve for a product produced by an individual firm in a perfectly competitive industry was perfectly elastic. It looks like this. Price, quantity. Here's what the demand curve looks like. There's the demand curve. It's not downward sloping at all, is it? It's horizontal. There's the demand curve. Here will be the price, $5, $10, $2.98, whatever it is. This means that the firm can sell one product at that price, 2 units of output at that price, 3 units up to his plant capacity at that particular price. Notice that as he produces more, this doesn't drive the price down as you might think an increase in supply would. And that's because the firm is so small relative to the total market that the little bitty amount that he can produce is not going to influence the market at all. It's like adding a handful of grains of sand to this vast beach. It's not going to affect the beach whatsoever. And so the price will not change as this particular firm produces more or less units of output. The demand curve is perfectly elastic because there are many, many, many sellers, and each of the units are identical. Lots and lots and lots of perfect substitutes. So now, let's look and see what the revenue relationships would look like if the demand curve were perfectly elastic. You know, the revenue relationships all stem from the demand curve, and the demand curve is the relationship between the price and quantity. Here's the quantity that the firm might produce. We'll call it Q there, quantity. It might produce 0. It might produce 1, 2, 3, 4, or 5. Maybe more, whatever the plant capacity is. Now let's look at the price at which they could sell these. Let's say this price here is 5. So if nobody bought it, you could sell 0 at 5. It could sell 1 unit of 5. It could sell 2 units at 5. Notice that it would not have to lower its price to sell additional products because it's not adding significantly to the supply when it produces more. 3 at 5, 4 at 5, 5 at 5. You can see that if we were to plot that set of relationships, we'd get a demand curve that looks like that. Now, total revenue is price times quantity. So let's look at what the total revenue would be. Total revenue, that would be price times quantity. Total revenue, price times quantity. Here, total revenue would be 0 times 5 is 0. 1 times 5 is 5, 2 times 5 is 10, etc. How are we doing? Okay. Now, let's derive average revenue. Now, your author doesn't say anything about average revenue, but I'm going to introduce you to the concept of average revenue because things are much easier to understand with the notion of average revenue, and the economic concepts become much clearer. Why he would not, or your authors rather, one of which is female, why they would not include a notion of the average revenue curve, I don't know, but we'll do it. Average revenue, AR. Average revenue is, of course, total revenue divided by quantity. Total revenue divided by quantity. If you can't read that, there's nothing wrong with your eyes. But that says that says total revenue divided by quantity. So, total revenue divided by quantity. Of course, that's 0 divided by 0. That's undefined. Total revenue divided by quantity is 5. Total revenue divided by quantity is 5. Total revenue divided by quantity is 5. You can see it's 5 all the way down. If we were to plot the average revenue curve, what you would find is that the average revenue curve is the same line as the demand curve. So we'll just put comma, average revenue, demand and average revenue, the same curve right there. As a matter of fact, the average revenue curve and the demand curve are always the same. The average revenue curve and the demand curve are always the same. Here's the reason why. Average revenue is equal to total revenue divided by quantity. All right, we've already defined that. But total revenue is price times quantity. So average revenue is price times quantity divided by quantity. Well, of course, these two cancel out, and so average revenue is always the price line, the demand curve. That's probably why your textbook authors did not specifically state anything about average revenue. But I think that understanding average revenue will make concepts a lot clearer. So, the demand curve and average revenue curve are always the same. Now there's one more curve that we have to derive, and that is the marginal revenue curve. So let's put a column here for marginal revenue. Marginal revenue is simply the change in total revenue. That's delta, total revenue, change in total revenue. How much does an additional unit of output add to total revenue? Well, as you can see, when we produce 1 unit, that increases total revenue from 0 to 5. The second unit increases total revenue from 5 to 10. That is, it increases it by $5. The third unit increases total revenue by 5. Fourth by 5. Fifth by 5. Now, if we were to plot the marginal revenue curve, what we would see that at 1 unit of output, marginal revenue is 5. At 2 units of output, marginal revenue is 5. At 3 units of output, marginal revenue is 5. If we were to go over here and plot it, you'd see that the marginal revenue curve for this firm would be the same as the demand curve and the average revenue curve. So let me slip marginal revenue curve in here like that. I apologize for being so sloppy. I know you will forgive me, though. Isn't that right? I thought so. Now that we've got this established, before we make another point, let's make sure we've got time. I'll make a little vid to follow this one. Stay tuned.